All right, guys, these are our atomic structure notes. Go ahead and start with whatever day it is. All right, we now know from our atomic history notes the model of the atom. We have protons and neutrons in the center with the electrons on the outside. So we got to think about the specific elements and how we write them. So if I just pull something off of this periodic table, I'm going to go with lithium. So we're going to copy that here. All right, so this is exactly what we see on the periodic table. That smaller whole number is the atomic number. And remember that that is how the periodic table is organized. That is considered the element symbol. And this element is lithium. And this is the average atomic mass. Now, every atom of a lithium does not have a mass of 6.94. There are different varieties, but the majority of them, or the most varieties, have a mass around that number. So if we had a periodic table of animals, and let's just say C stood for cat, and it said the average weight of a cat is 12 pounds. Well, we know that there's all different sizes of cats. You might have a tiny teacup kitten or a really, really big cat, but this would be the average. Now, that would be for animals, which this would be a huge table, and it would be way off because we know that like dogs, for instance, go all the way from 4 pounds to over 100 pounds. Elements, not so much, in a much smaller range. These aren't in grams, they're not in pounds. These are tiny, tiny units called atomic mass units. And as we go further into chemistry, we'll talk about how to use those in measurements and calculations. All right, so when we write this, and it's not on a periodic table, we'll label this. This is the symbol. That's the atomic mass. And we'll call this the mass number because that's always going to be a whole number when you write it like this. And that's the atomic number. Mass number is different than average atomic mass. This is the average of all the varieties that exist. When they give you a mass number, it's a whole number, and that is the exact one you're talking about. So it's not an average. You may or may not have something over here. This is there only if it has a charge. So if it's not neutral, if it's positive, or if it's negative. All right, so let's look at this. If I have, let's see, if I have sodium, and I tell you that in this sodium, it has 11 protons, 11 electrons, and 12 neutrons. How would we write this symbol? Well, first you'd have to know, what is the symbol for Na? For sodium, I mean. I just said it. It's Na. Then the atomic number is always how many protons you have. So this atomic number is 11. And the mass, all the mass comes, well, 99.9% of the mass comes from the nucleus. And we know that the nucleus is protons and neutrons. So if I do 11 plus 12, I get 23. Next thing I'm just going to look at quickly, do I have a charge? 11 positives, 11 negatives. Those cancel out, so this is neutral. And that is how I would write this element symbol. Again, we will write atomic number equals number of protons. The mass number equals the nucleus, which is protons plus neutrons. How are we going to get the charge? What you can do is you can take the number of protons minus the number of electrons, and that will give you the charge. But a lot of times with charge, it is just easier to look at it and think 11 positives, 11 negatives, oh, they cancel out. All right, I'm going to have you try one. All right, let's see how you did. When I look at the periodic table, carbon has, let's see, if I just write it like this, all right, the protons, 6 of them, same as the atomic number. I didn't tell you it had a charge, so electrons must be the same. And then for neutrons, if I say the mass is 12, 12 minus 6 is 6 neutrons. So when I write the symbol, that is how I would write the symbol. This is the periodic table. This is the breakdown. The more we practice this, the easier it will get. Obviously, we can't do it without our periodic table in front of us. Another thing I want to look at that will be talked about in your next video are the energy levels, or how many shells. So we'll just make a side note. This is also like the layers of electrons. Around the nucleus. And there's an easy trick. If you know that these are periods and periods go across in rows, so these are periods, this would be period 1, 2, 3, 4, 5, 6, 7. Whatever period it's in is how many shells of electrons it will have, or how many layers. So this is only in the first period, so it only has one layer. Magnesium is in the third period, so it will have 3 layers. So the trick to figuring that out is it matches the period or row number it is in. All right, let's talk about something called isotopes. These are variants of an element or different varieties of an element, and how they're different is they differ in number of neutrons. And we remember that protons, those guys have mass. Neutrons, they also have mass. Electrons, on the other hand, it's almost like a tiny piece of dust. If I go to the doctor's office and I step on the scale and I say, hold on, there's a piece of dust on my shoulder, it's not going to make a difference. And that's what electrons are. Yes, they're there. Yes, they are matter, but they have insignificant mass. And the reason I mention that is if these have different neutrons, that means they also have different masses. Now, protons can never change. The proton is the identity of the element. If you say, well, I have beryllium, but I take away a proton, so now it only has 3 protons. Well, then you don't have beryllium. You just made lithium, and we can't do that. So beryllium will always have 4 protons. If something had 3 protons, it's not beryllium, it is lithium. That is the identity of the element. So with the isotopes, you will have to be told either the number of neutrons or the mass so you know what you're working with. So there are different varieties of carbon, and there is carbon 12 and carbon 14, and there's actually a few more. Now, I wonder which one of those do we find more readily in nature? Which one of those is most abundant? Well, if I look on the periodic table, the average mass is 12.01. So do you think we have a lot more carbon 12 or a lot more carbon 14 in the world? Well, since 12 is so close to 12.01, we must have a ton more carbon 12 than carbon 14. What is different about these? Carbon 14 has 2 more neutrons than carbon 12. So it would also be heavier than carbon 12. All right, we always put a dash, and you might see it written out with the word in a dash, or you might see Just that. C for carbon -12. Now let's look at this in a table to try to solve for some of these. I'll put name, symbol, number of protons, number of neutrons, number of electrons. All right, if we are given the name iron 57, right away we know this is not the variety on the periodic table because it has this dash telling us it's an isotope, and this isotope's mass number is 57. How to write this symbol? Well, iron is Fe, and the mass goes on top. Since protons never change, we use the atomic number, goes on the bottom, 26. Now, for number of protons, it is the atomic number, 26. To get neutrons, we know that the mass is protons plus neutrons. So I have to think, what plus 26 equals 57? And to solve this, you can do 57 minus 26. And I get 31. Number of electrons. Nothing here is telling me it has a charge. So electrons, since it is neutral, will equal protons. So if there's no charge, electrons equals the number of protons. All right. I'm going to give another one. 18, 8, oh. All right, now you solve it and we'll check our work. You should have, this is oxygen, variety 18, number of protons, 8, neutrons, well, neutrons plus protons equals the mass, so it looks like 10. That's just dividing my work. And then number of electrons, there is no charge, so 8. All right, let me give you another one. You go ahead and do it, and let's check our work. B for boron, it has a mass of 9, atomic number 5. I got that from the periodic table. Number of protons, 5. Neutrons, what plus 5 is 9? And the answer to that is 4. Number of electrons, same as protons, 5. All right, let's try one more of those. This time, you have 3 protons, 4 neutrons, 3 electrons. You have to figure this out. All right, to get the element, it's element number 3. Element number 3 is lithium. And the mass is protons plus neutrons, so the mass is 3 plus 4, 7. And it was atomic number 3. Next up, we have ions. And these are elements with a charge. We have two new vocab words, cation, anion. Cations have a positive charge, anions have a negative charge. So whatever you have to do to remember that, I like to think of the cation having a plus sign in that T right there, and that helps me remember. How would they have a charge? Since protons don't change, they different number of electrons. So ions have a different number of electrons. If I look at magnesium ion, here is magnesium, located on your periodic table. Magnesium has a mass of 24 and an atomic number of 12, and it has a charge of positive 2. So looking at this, we're going to try to figure out protons, neutrons, and electrons. All right, number of protons, same as the atomic number, so 12. Number of neutrons, what plus 12 is 24? 12 plus 12 is 24. Electrons, if it were neutral, it would have 12, but it has a positive 2 charge. So to become positive, do we gain 2 electrons? Do we gain 2 negative things to get more positive? Or do we take away negative things to become positive? And to become positive, we take away negative things. How many electrons do we need to take away? 2. 2 negative things need to go away. We had 12 if we were neutral, but if we take 2 away, we will now have 10. Again, if you have 12 positives, 10 negatives, overall, that would leave you with a charge of positive 2. If something is a cation, there's a specific way we name things. So for cations, which are positively charged, you use the element's name plus the word ion. I knew magnesium was going to form a positive charge, that's why I put magnesium ion. If it is an anion, which means it has a negative charge, you use the element name and the suffix IDE. For example, instead of oxygen, if it has a negative charge, we put oxide. Instead of nitrogen, if it has a negative charge, we would put nitride. So let's go through the ones that form negative ions. This would be, instead of nitrogen, nitride, oxygen, oxide, fluorine, fluoride, phosphorus, phosphide, sulfur, sulfide, chlorine, chloride, selenium, selenide, bromine, bromide, iodine, iodide. And those just take getting used to, and we will use them a lot so that you get used to when you use "ide" and how that word forms. Let's look at another example. Sulfide. Just from the name, we know this is an ion. So the symbol 32 over 16s -2, and I'm giving that to you. You're not figuring that out right now. What I do want us to figure out is number of protons, number of neutrons, and number of electrons. All right, protons is the same as the atomic number. Neutrons, 32 minus 16 is 16. Protons plus neutrons equals the mass. Electrons, we have a negative charge. So to get a negative charge, are we going to have more than 16 or less than 16 negatives? To become more negative, do we need more than 16 negatives or less than 16 negatives? To become more negative, we need more. We need 2 more. And if we really look at that, we have 16 positives, 18 negatives for an overall charge of -2.